So in this lesson we're going to start by looking at our properties of angles, and we'll do this over the next couple of lessons to cover all of them. We're going to start with our basics and just explaining to you the different types of angles that you're expected to know, such as acute angles, right angles, obtuse angles, half turns, reflex angles, and full turns. Okay, we'll start off with what an acute angle is. So these are some examples of acute angles. I will look at in a separate video how we would measure an angle precisely using a protractor, but for the minute we're just going to look at the basics of what they would actually look at. These angles are acute because they are less than 90 degrees. Now notice for less than a quarter turn. A quarter turn is another way you'll sometimes hear a right angle described. We'll come to that in a wee second. So generally, if you consider a right angle, it looks like this. It's 90 degrees, and sometimes you'll see it indicated on a diagram with a square, indicating that it is a right angle. You'll see it in shapes such as squares and rectangles. As the corners, and you think of the corner of a table, that's generally a right angle, which is 90 degrees. An acute angle is less than that. So if you imagine a door opening, this far will be a right angle. If it's any less than that, it's what's known as an acute angle. So examples in terms of numbers may be 35 degrees, 42 degrees, 9 degrees. Any of those types of angles would be what's known as an acute angle. And the angle, just another thing to point out, is indicated by the arc of the circle. So it's not this angle around here, it's this angle here we're looking at, that's indicated by the arc of the circle in each of these. Okay. Next, which we've already touched on, is right angles. So right angle, again, if you think of the corner of a table, you think of a square, a rectangle, that is what a right angle would look like, and it's usually indicated on the diagram with a square representing the angle, and sometimes it's referred to as a quarter turn. And when we cover topics such as bearings, compass directions, and things like that, we will also come back to that. The next angle in terms of size up from a right angle would be an obtuse angle. An obtuse angle is between 90 degrees and 180 degrees. 180 degrees is what's known as a half turn. Okay, so these are some examples, again looking at the arc of the circle, of what an obtuse angle might look like. Okay, so it's, as you can see, if it was a right angle, it would be opened about here. It's larger than a right angle, yet it hasn't opened as far as that. So between a right angle and a half turn is what's known as an obtuse angle, and this is what it would look like. Up from that, we then have angles about a straight line, also referred to as a half turn, because again, just touching on compass directions, if you were to face north and turn 180 degrees, you'd be facing the total opposite direction, hence why it's sometimes referred to as a half turn. So if you're facing north and turned 180 degrees, you'd be facing south, the total opposite direction. Okay, and they will always generally look like this, hence why it's called angles about a straight line, or angles on a straight line. Larger than a straight line, angles on a straight line, is what's known as a reflex angle. So this is an angle that is between 180 degrees, a half turn, and 360 degrees, which is a full turn, and we'll come to that in a wee second. 360 degrees being a full turn, you end up back in the same position. So again, say if there's a line here that's a half turn, we went further than that, and the same with over here. So 181, 200 degrees, 270 degrees, all examples of what's known as a reflex angle. And then the largest angle referred to today is 360 degrees, which is what's known as a full turn. And the reason for that is because if you were to, again, let's imagine this was north, turn 360 degrees, you would end up facing the same direction. The hands on the clock, if they go around one full turn, that's 360 degrees. That's another way of thinking about it. Okay, so those are the different angles we have to know and to be able to describe. All right, we're going to look over this video and the next one of some of our basic rules of angles. So we're going to start off with angles on a straight line, and we know that an angle on a straight line is 180 degrees. So if we have more than one angle on a straight line, like in these examples, they should add to 180 degrees. So that is the first rule that we're going to look at here. So in this type of question, if I have asked to find x, I have this angle here of 135 degrees, an obtuse angle, and this angle that I don't know. Because both these angles lie on a straight line, and we know that angles on a straight line are 180 degrees, we simply find x by subtracting 135. Okay, so you do 180, take away 135, which would give me 45. So therefore x would equal 45 degrees. Okay. The second example is something similar to this. All right. This time we have three angles, but again, because they're on a straight line, all three angles should add to 180 degrees. So to find the one that we don't know, we add the two that we do know, and we simply subtract that from 180 degrees. So first off, add the two angles that we do know, 65 plus 37. 5 and 7 is 12. Get 102, and then we're doing 180. Take away 102, and that should give me 78 degrees. So x equals 78 degrees. Okay, so two wee bits working out for that one, but again, the same principle, angles on a straight line adding up to 180 degrees. The second rule that we'll look at is similar, only as angles about a full turn this time. And angles about a full turn will add to 360 degrees, because we know that a full turn is in fact 360 degrees. So if I was to start here, go all the way around here, these two angles together should give me 360. So how we find the missing one is take away the one that we do know. So we're just doing 360, take away 210, which would leave me with 150. So x is 150 degrees in this case. All right. Our second example, again, something similar, only this time we have three angles, again, about the 1 point. How we work this out is add the two angles that we do know and subtract that away from 360 degrees. So we'll do 115 plus 87. 5 and 7 is 12, carry that over. 8, 1 and 1 is 10, write the 0 down, carry the 1, and I get 202. So we're doing 360, take away 202, which would give me 158. So x is 158 degrees. So that's as far as we'll go today. The next lesson on angles, we will carry on with our next set of rules. Just one other thing just to point out is that we will eventually look at how we measure angles accurately. When you come across these types of questions in an exam, it will generally inform you that they're not drawn accurately. So you have to do this bit of working out in each case to calculate the missing angle. It's not a case of getting a protractor out and being able to measure it. Okay, put some questions up for practice, and anything you're unsure about, just ask.